The point given is on the terminal side of an angle theta. Find the exact value of each of the 6 trigonometric functions of theta. And our point, P, is the point -4, 3. Now there are multiple ways to approach this problem. So the first thing I want to do is kind of give you a visualization of what we're looking at. So if I were to sketch a coordinate plane, so here's my XY axis, and no, they're not straight, and I were to graph the point -4, 3, well, that is going to be in the second quadrant because the X value is -4 and the Y value is 3. So essentially, if I put my point at approximately where I would say -4, 3 is, I could draw a line from the origin through that point. Of course, it would be nice if it was a little bit more through the point, but we have that. So what we're really looking at is that this angle right here would be our angle theta, and then this little angle in the middle, this would be our theta prime. And so using this point, we can find the 6 trig ratios for theta based pretty much on a right triangle. And so our right triangle, our right triangle would then go from that point straight down, right, vertically down from that point to the x-axis. So here's what we know about this triangle then. We know that the distance from -4 to 0, that this distance in this right triangle is 4. And we know that the distance up the vertical line from 0 up to 3, we know that that distance is 3. And then this part from the origin to our point, this is the part that we call r. We know that we can find the length of r using the Pythagorean theorem because this is a right triangle. So in other words, 3 squared plus 4 squared is equal to r squared. Well, 3 squared is 9, and 4 squared is 16, and 9 plus 16 is 25. So 25 is equal to r squared. If 25 equals r squared, then 5 equals r, because we take the square root of r squared, we get r. We take the square root of 25, and we get positive or -5. But because this is a length, the answer is 5. Now, what if I didn't want to draw out this? Here's the other way we do this. We look at this and we say, well, here's our x value, here's our y value. So this is -4 squared plus 3 squared is going to equal r squared. In other words, x squared plus y squared equals r squared. Now, why do we do that? Well, if this angle over here is angle theta, then we know that the sine of theta is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. How does that play out if we don't draw the picture? Well, it plays out like this. The sine of theta, which is equal to the sine of theta prime, right? So the sine of theta is equal to the y value over the r value. And the cosine of theta is equal to the x value over the r value. And the tangent of theta is equal to the y value over the x value. So those are 3 of the 6 trig ratios. The other trig functions are the reciprocal of the sine, the cosine, and the tangent. So we have the cosecant of theta, which is equal to the reciprocal of the sine. So in other words, it's r over y. And we have the secant of theta, which is equal to the reciprocal of the cosine. So it's r over x. And the cotangent of theta, which is the reciprocal of the tangent. So that's equal to x over y. So now we have the formulas for all 3. We also have a formula for how do I find r. So we're going to go ahead and finish this. Of course, we do know already r is equal to 5, but if I go back to my -4 squared plus 3 squared is equal to r squared, -4 times -4 is 16, plus 3 times 3, which is 9, 16 plus 9 is 25, so 25 equals r squared. so r equals 5. So I can still use this r equals 5. So now how do I find the cosine, right? Well, it's the y value over the r value. So in this case, the y value is 3, the r value is 5. So the cosine of this angle theta is 3/5. Sorry, the sine of this angle theta is 3/5. The cosine is x over r. In this case, x is -4, so we have -4 over 5. The tangent is y over x. So it's 3 over -4, but we don't leave a negative in the denominator. So either put it in front of the whole fraction or just put it in the numerator, but it becomes -3/4. The cosecant is the reciprocal of the sine, or r over y, so it's 5 over 3. The secant, the reciprocal of the cosine, or r over x, so it's equal to -5 over 4. Now remember, again, the negative goes in front or it goes in the numerator. We don't leave it in the denominator. And then the cotangent is is x over y, or the reciprocal of the tangent. So it's -4 over 3. So this is how I use the coordinates on a point when the angle is in standard position and the terminal side goes through that particular point. This is how I would use those coordinates to find the 6 trig ratios.